So here's a video looking at the stoichiometry review problem set questions 9, 17, and 20, all looking at concentrations and neutralizations between acids and bases. So let's say that, so this question number 9, we've got our 50 cubic centimeters of this concentration of sodium hydroxide. I'm going to go ahead and do this question twice. I'm going to do it once the long way and then again a slightly shorter way. So first, the long version. I'm going to turn my cubic centimeters into cubic decimeters. Remember that there are 1,000 cubic centimeters in every 1 cubic decimeter, which means that we have divide by 1,000, and that's 3 zeros. We're going to move our decimal place 1, 2, 3 to the left, 0.0500 cubic decimeters of sodium hydroxide. Now I'm going to turn my cubic decimeters of sodium hydroxide into moles using the concentration. So if I have 0.0500 cubic decimeters of, remember that of means multiply, 0.120 moles per cubic decimeter of sodium hydroxide. What's going to happen here, my decimeter to the positive 3, my decimeter to the minus 3 cancel each other out. And so now I can do this math, and I'm going to get 0.0500 times 0.12 is going to give us 0.006 moles of sodium hydroxide. So now I'm going to go ahead and think about how I can use this to neutralize these different acids. I'm going to start with this guy. So I know that sodium hydroxide and phosphoric acid react, neutralize. We're going to get sodium phosphate and water. Sodium, remember, is a +1 and phosphate is a -3. That means I need 3 of those guys, which means I need 3 of those guys, which means that I have 3 hydroxides and 3 hydrogens. I'm going to make 3 waters. Now I can go ahead and use my moles of sodium hydroxide and convert to moles of phosphoric acid. So if I have 0.006 moles of sodium hydroxide, and it's a 3-to-1 ratio, there's an invisible 1 there, 3 sodium hydroxides to 1 phosphoric acid. 0.006 divided by 3 is going to give us 0.002. Sodium hydroxide cancels out moles of phosphoric acid. So now I'm going to look at what I'm actually given here. Do I have that many moles of phosphoric acid? I need to turn my cubic centimeters into cubic decimeters, divide by 1,000 just like I did over here. We're going to go backwards. 1, 2, 3. So this is going to be 0.0125 cubic decimeters of means multiply, 0.080 moles per cubic decimeter. 0.0125 times 0.08 gives me 0.001 moles of H3PO4. I need 0.002 moles. I only have 0.001 moles. That's not my answer. Do same idea with this next one, but now I need to turn my, I need a new balanced equation. So I still have sodium hydroxide, but now I am adding to that some ethanoic acid. This H and this OH are going to neutralize. We're going to end up with sodium and water. And I have a lovely 1-to-1-to-1. So I'm going to go ahead and turn my cubic centimeters of my methanoic acid into 123.0250 cubic decimeters of 0.120 moles. Oopsie. It's a 1-to-1 ratio, so I need equal moles of sodium hydroxide and my ethanoic acid. 0.025 times 0.12 is going to give me 0.003. 0.003. 0.006. Not a match. Next one. Now I have an H2SO4, NaOH, and H2SO4. going to make sodium sulfate. Sulfate's a -2, sodium's a +1. That's going to be a 2. So I need a 2. My 2 hydroxides and my 2 hydrogens are going to make 2 waters. So now I have a 2-to-1 ratio. My 0.006 moles of sodium hydroxide to sodium hydroxide to 1 sulfuric acid is going to give me 0.003 moles of H2SO4. If I turn this guy into moles of H2SO4, turn this backwards, I've got 0.0250 cubic decimeters times 0.120 times 0.120 is 0.003 moles of sulfuric acid. I think we have a winner, but let's do the last one just in case. This one might be it. Same thing here. We're going to be write our equation NaOH and HNO3. We're going to make sodium nitrate and the water. This is a +1 -1, so I have a 1-to-1 ratio. So I have this 0.006 moles of sodium hydroxide. I also need 0.006 moles of nitric acid because they're in a 1-to-1 ratio. So I'm going to turn my cubic centimeters into cubic decimeters. 1, 2, 3, backwards. 0.050 times 0.06 is going to give me 0.003 moles of nitric acid. That's bad. I need 0.006. My answer is C.